To understand the meaning of a negative exponent, let's look at two ways to perform the division problem a to the third power divided by a to the fifth power. Method number one is to write out the factors of the numerator and denominator and then simplify the fraction. A to the third power is a times a times a, while a to the fifth power would be a multiplication problem involving 5 factors of a. Notice that there are 3 factors of a which appear in both the numerator and the denominator. So we can remove those common factors, resulting in the answer 1 over a squared. Method number 2 is to use the quotient rule, which states that when dividing powers having the same base, we keep the base and subtract the exponents. So in this case, we have a to the power of 3 minus 5, which is a to the negative 2 power. Since 1 over a squared and a to the power of negative 2 are answers to the same problem, these two expressions must be equivalent, and this suggests a definition for negative exponents. A number raised to a negative exponent is the reciprocal of the same number raised to the opposite or positive exponent. This definition can be expressed algebraically as follows. A to the negative nth power equals 1 over a to the nth power. Now let's use this definition in some problems. First, we will express some fractions using negative exponents. Fraction number 1 is 1 over x to the 9th power. This is the reciprocal of x to the 9th power, so it's equal to x to the negative 9th. Fraction number 2 is 3 over n. This is 3 times 1 over n, and 1 over n is the reciprocal of n to the first, so it's equal to n to the negative first. Therefore, 3 over n is equal to 3 times n to the negative first power. Now let's simplify some expressions containing negative exponents and express our answers using positive exponents. In problem 1, we have 7 to the negative 2 power. This is the reciprocal of 7 squared, so it's equal to 1 over 49. Similarly, in problem 2, negative 8 to the negative 2 power would be 1 over negative 8 squared, so it's 1 over 64. The properties of exponents that we've learned previously can be applied to negative exponents as well as positive exponents. So in problem 3, we can use the product rule to multiply n to the 6th times n to the negative 9th. We keep the same base, n, and we add the exponents, 6 plus negative 9. This is n to the negative 3, which is the reciprocal of n cubed. So we have 1 over n cubed as our answer. In problem 4, since we're dividing powers of the same base, we subtract the exponents. In this case, we have x to the negative 3 minus negative 5 power, or x to the negative 3 plus 5, or more simply, x squared. Problem 5, 1 over n to the negative 4th, can be simplified a bit more easily if we remember that 1 is equivalent to n to the 0 power. And now we can use the quotient rule to write n to the power of 0 minus negative 4. This is n to the power of 0 plus 4, or more simply, n to the 4th power. Finally, in problem 6, we have a product raised to the power of negative 3. So we can take each factor and raise it to that power of negative 3. Thus we have 2 to the negative 3 times a to the 4th to the negative 3 times b to the negative 7th to the negative 3. Applying the power rule, we now have a to the negative 12th power, since we multiply 4 times negative 3, and b to the positive 21st power, since we multiply negative 7 times negative 3. Now our first two factors, 2 to the negative 3 and a to the negative 12, have negative exponents, so we need to find reciprocals of those. However, b to the 21st power has a positive exponent, so we don't use the reciprocal of that factor. We keep it in the numerator. Thus our final answer is b to the 21st power over 2 to the third, which is 8, a to the 12th.